So let's look at the following example that essentially deals with compressive stresses. Let's suppose that a brass rod with a diameter of 30 centimeters and a height of L0 rests vertically upward on the ground. Now a man with a mass of 80 kilograms climbs on top of that rod, and the rod compresses a distance of change in L. Now this example has two parts. Let's begin with part A. Determine the percent decrease of the rod assuming Young's modulus for brass is 100 times 10 to the 9 newtons per meter squared. So let's begin with our diagram. In the diagram we have our column, we have the rod, that is a height of L0. And then a man climbs on top of that rod, and the force of gravity acts on the man and in turn acts on the rod, compressing the rod a distance change in L. Now, in order to calculate the percent decrease, we first have to calculate the fractional decrease of our object. And to calculate the fractional decrease, we have to use the following equation. Young's modulus, E, is equal to our stress over strain, where stress is force per unit area and the strain is our fractional decrease. So we're looking for this entire quantity. So we basically take this quantity and bring it over to the left side and take E and bring it to the right side. And we get the following result. Our fractional decrease of the object of the rod is equal to force divided by area times our E, Young's modulus. Now force is simply m times g, because the force that acts on the rod is simply mass times g, mass of the object, the person, times the gravitational constant. So we know what m is, we know what g is, we know what e is, and we can calculate what a is. A is simply the cross-sectional area of the rod. So we know what our diameter is. To find the radius, we simply divide by 2, and then we divide by 100 to convert centimeters to meters. We multiply by pi, and we take the square of the radius, and that will give us the cross-sectional area. So let's actually solve. The change in L divided by L0. So change in L is simply our compression distance. L0 is the initial height of our column of the rod. And this entire fraction, this ratio, is simply the fractional decrease of our object. And it's equal to, well, the mass is 80 kilograms, the g is 9.8 meters per second squared, the area is 0.15 meters squared times pi, and E, Young's modulus, is 100 times 10 to the 9 newtons per meter squared. So we multiply and we divide and we get approximately 1.11 times 10 to the negative 7. So this is unitless because this is a ratio of meters to meters. So this is our fractional decrease. And to get the percent decrease of the rod, we simply take this quantity and we multiply it by 100%. And we simply get 1.11 times 10 to the negative 5%. So this is our percent decrease of the rod. Now let's move to part B. When the brass is compressed, each atom throughout the object, throughout the brass rod, moves closer to one another by exactly the same fractional value. Now, if the interatomic space between any two atoms is initially 2 times 10 to the negative 10 meters, find the change in distance between any two atoms after our object compresses. So let's suppose before the object compressed, we're exaggerating here of course, but let's suppose here's one atom and here's a second atom. And before the object compressed, the distance between these two atoms was 2 times 10 to the negative 10 meters. Now after the person climbed on top of the object, these two atoms moved closer to one another. And we want to calculate what the distance is, what the change in distance is. How much closer did the two atoms move? Well, to calculate this distance, we simply take this whole distance and multiply by the fractional value 1.11 times 10 to the negative 7. So we take our distance, so 2 times 10 to the negative 10 meters, and we multiply by the fractional decrease 1.11 times 10 to the negative 7, and we see that our two atoms got closer by this distance, 2.22 times 10 to the negative 17 meters.